In this lesson, we're going to describe different types of DBMSs. I already told you that there are many types of database management systems, and the choice depends on a lot of things like your budgets and so forth. So now let's describe these different types so that we can see maybe which one we would go for or which one we would root for. The different types of these database management systems are based on data models. And here is what we're talking about. There is what we call a relational database management system. In relational database management systems, these are the most widely used database management systems today. They are relatively easy to use. Relational database management systems are named so because of the characteristics of normalizing the data, which is usually stored in tables. So in relational model, the relational model relies on normalizing data within rows and columns as in tables. The data can be related to each other in the same table or other tables which has to be correctly managed by joining one or more tables together. So let me just put this into perspective for you. Coming back to my example of our ATM and our bank, all of us have got accounts there. By accounts, we literally means all of us who have got records there that show our activity with the bank, how much we have, how much, and stuff like that. So once we have got all that relationship with our bank, we can actually have this information being used. For example, we can actually have a different table representing our amounts, just like on your phone app. If you've got a phone app with your bank, you have a place where it shows you how much money you have in the bank. You have a place where it shows you how much maybe you owe. You have a place where it shows you the debit orders and so forth. So those are different particular tables, and they are related to each other on your one record. So that's why then it's then called a relational database system. And I'm confident in saying this because that's what actually banks use. They actually use such kind of tables and such kind of databases. And there are many examples of these, but as I mentioned before, they're actually manipulated using what is called structured query language, which is a programming language, literally, where you are actually able to give instruction to your database to say delete this, insert this, and so forth. And these relational database management systems include the example I gave earlier, which is Oracle. There's also Microsoft SQL Server, obviously coming from Microsoft. Oracle comes from a company also called Oracle, which is quite big in this database management system business. And then we also have IBM DB2, which comes from IBM. We also have MySQL. MySQL is free, so in case you want to experiment with databases and so forth, you are free to download MySQL and you can actually experiment with it. The others that I've mentioned actually come from companies which commercialize them, so they sell them. So, but do not ever feel like MySQL is I'm actually now confusing the pronunciation of this name. It's MySQL. Some people say MySQL. So if you hear people say I'm using MySQL, they literally mean this particular spelling, MySQL. It's actually free, as I mentioned, but that doesn't mean that it's actually weaker or not as good. No, from experience, it's actually as good as the others. The only difference is the people behind this particular thing. Certain people are in the idea of saying certain technology should be for free. Certain people are saying it should be sold. So you see Microsoft selling theirs, IBM selling theirs, MySQL saying no, it will depend on donations. So if you really like it, you can donate to us. We won't sell it to you, but we'll give you a very good program to use so you can experiment with them. Anyway, the other type of a database management system is the file-based database management system. Flat file-based, sorry. So the flat file-based database management system are probably the simplest of them all. These are sometimes called flat models. They come in human readable text formats such as your binary, as well as in binary formats. These are ideal for standalone applications holding software configuration and native format storage models. Flat files in a formatted row and column model rely on assumptions that every item in a particular model consists of the same data. And one common type of this type of database is called the CSV, which is comma separated values, and another is a spreadsheet such as your MS Excel. So flat file, if you're thinking about what it is, here it is. This is a database about you guys, containing how we're gonna train each other, even what I'm now putting here, your register, and so forth. So that's what we then call a flat file. And then we can actually have what are called comma separated values, which we can even use with a notepad. So we just literally separate our information with commas, and we can now easily import it into Excel and everything. Those are some advanced stuff. We could have looked at that, but that would take us a lot of time. But basically speaking, this is the simplest way of storing our data. Literally, we call it the traditional way of storing our data, and it's called a flat file-based database management system. Simple to implement, but not so simple when we now need to manipulate it, especially when we've got a lot of information to deal with. So just keep that in mind. Then we've got what are called hierarchical database management system. I hope I pronounced that correctly. So hierarchical database management system operate on the parent-child tree-like model. These normally have a one-to-n relationship and are good for storing data with items describing attributes, features, and so forth. These could store a book with information on chapters and phases and so forth. Before you think too much about this, literally, if ever you have used such applications online, which can open a book, for example, you'll find that there are links now to the chapter that you want to go. Those applications will be using what is called hierarchical database management system. By the way the hierarchy comes from order from top to bottom. So if we were to say a hierarchy of a house, normally we have father at the top, mother, followed by children. A hierarchy of a school, it will probably have principal at the top, followed by vice principal, and so forth down to the students and stuff like that. So that's what we mean there. So we're just saying the relationship between the principal and the students is that the principal is the school and the students need the school for them to learn. So in a real world, we have something called an XML document. Normally, that's the ones that are then used to program. XML, by the way, is another programming language. Those are the ones that are used to program how you interact with such features on a website, such as your books and so forth. So you can actually feel like you're opening a book in real life. Yet, you're not really opening a book, you're clicking links that lead you to the next page. But you wouldn't really think about that, especially if it's a tablet. It can actually give you that feeling that you are, swiping next and going and opening a page and going to the next page. They can even put sounds to go along with that. All that is then we are able to achieve that using a hierarchical database management system. And that particular application is actually hierarchical. So it's moving from one thing, linking to another, and so forth, from the top to the bottom. Then we have network database management system. A network database management system uses data models similar to hierarchical database management systems. The major difference here is that the tree structure in the network models can have a many parent to many child relationship model. Let's think of it this way, without having to look at their very difficult examples or something like that. Network. Just think of a network. Think of the way your computer is connected to the internet right now. If you're like me, it's probably connected to your phone. So you're hotspotting your phone, and your computer is able to get the internet from that. Now, that particular connection can actually have your phone also connecting to another device and giving it the internet, which is true. You can actually have two computers which are connected to the same phone. But remember, your phone, where is it getting the internet from? If it's mine, it's getting it from MTN. So my phone is a parent to these two computers, and my phone is a child to MTN in terms of the network structure. We can actually have a parent being a parent of two or more devices, and a child being a child of two or more devices. So it's no longer really a hierarchy. It's more like branches of a tree, which branch off and so forth like that. And then they end up even connecting back to each other, forming a circle and so forth like that. So that's what networking is all about. If you think about it, all our devices are always connected, connecting another, connected and connecting another. And there's no, if you really, in the long space of events, you'll see that the relationship between which one is the child and which one is the parent can then become a little bit blurry, because at one point, maybe you actually have your computer connected to your phone to use the Wi-Fi. And you also have your phone connected to your computer via the USB to charge the phone. You understand? So at that point, you have two networks going on. So that USB can actually be used to transfer songs from your computer to your phone. And your phone is actually giving your computer the internet. So as you can see now, which one is being connected to and which one is connected to which becomes a little bit blurry. That's a network database management system in a nutshell. You actually have these particular systems networking with each other and being related to each other in a way that I just described right now, and being able then to give you back your information. Then we also have what is called Object-Oriented Database Management System. Object-Oriented Database Management Systems borrow from the model of Object-Oriented Programming Paradigm. In this database model, the object and its data or attributes are seen as one and accessed through pointers rather than stored in relational tables. Right. Again, we'll go a little bit advanced here. What we mean by object-oriented programming is that there is programming, simple and straightforward, writing code for a computer. There's then what we call object-oriented programming, where we store each group of codes as an object, and they have attributes. And those groups of codes are then run at the same time, or some of the things in that particular object are run. For example, make the computer screen brighter and so forth. Those could be the instruction in that particular object. Now, the question then becomes, how do we access that particular object? We use what are called pointers. This is very advanced, but I'm just trying to put it in simpler terms. Pointers are almost like addresses in real life. So those pointers can point to the exact object that you're looking for in your lines of code. In this case, in your database. So your information is accessed not using the relationship it has to another source of information, like in the relational database, which is the most popular one. It is actually accessed using a pointer, using an address. So these addresses, it's advanced to explain how they are come up with, but they are then used to identify what information you are looking for. So once you want to look at a certain piece of information, you then have to go through to its address, and then you have that information. You can close that up and go to the next address and so forth. So that's object-oriented database models for you. They're a little bit difficult to give examples over, because we'll then have to understand what is object-oriented programming, which if you do understand, I think the example that I just gave with addresses, that totally makes sense without a problem. But you don't really need to scratch your head over all of that. All we needed to do was to understand what database management systems are and have an idea of how they work. Let's meet in the next lesson.